Our fifth lesson is going to involve conditional statements. Conditional statements. Our goal is to be able to write conditional statements and find their truth values. So there's obviously some vocabulary terms here. We need to know what conditional statements are. We need to find out what truth values are. And in fact, here is a whole list of vocabulary terms that we're going to have in this lesson. Again, this is going to be a two-parter, so we'll only get through about half of these words, and then we will work on the other half the next time. But first of all, let's understand what a conditional statement is. Basically, a conditional is just an if-then statement. If I close my fingers in the door, I will scream. All right? If I trip and fall on the stairs at the school, then I will be embarrassed. These are if-then statements, and they may have truth to them, they may not have truth to them. We will think about, can we flip those statements around? What is the condition that implies I'm going to be crying? What is the condition in which I will be embarrassed? How do those things work together? Is it true that if I'm embarrassed, then I fell down the stairs in front of everybody? Or is it only true that one direction? All right, so we're going to be thinking about those in multiple different aspects. Each condition has these two parts. They have the hypothesis and they have the conclusion. The hypothesis is the phrasing, the part of the sentence that comes after the word if, all right? The conclusion is the part that comes after the then, all right? This is the result. This is the condition. This is the result. The condition, the result. And we usually represent it in this form. It's kind of a shorthand notation for hypothesis, then conclusion. If hypothesis, then conclusion, where P is the hypothesis and Q is the conclusion. So you might see that notation. We're probably not going to write it too much on our work, but we will use it to kind of summarize and visualize how to write our sentences and how to think about certain concepts, all right, throughout this course, especially throughout this semester, all right? And then we'll see what happens next semester. So there will be questions where I simply say, tell me the hypothesis, tell me the conclusion. So in this situation, so you don't have to write too much on your notes, copy this sentence down, and then I want for you to underline the hypothesis. Well, if hypothesis is the part that comes after the word if, then this is our hypothesis. And then I'd like for you to circle the conclusion. So then, the conclusion. Then the lines are coplanar. So if two lines are parallel, then the lines are coplanar. All right, this is a true statement. Parallel lines have to be in the same plane. One of the strategies we talked about for drawing planes, labeling planes, determining if points are coplanar, etc., was to see if we could draw a rectangle, or a parallelogram is how we described that. And so here's a situation where if the two lines are parallel, then the lines are coplanar. We've identified the hypothesis does not include the word if. The conclusion does not include the word then. So we want to make sure that we are being very careful with that. Notice how also we are reinforcing concepts from the first part of this unit. All right, what does coplanar mean? Oh, in the same plane? Okay, cool. What about this one? You can register to vote if you are at least 18 years old. So the hypothesis comes after the word if. So this is going to be our hypothesis. That's our condition that sets up the situation and draws this conclusion. You can register to vote. Okay? So we would circle then that conclusion. It's not always that the if comes first and the then comes second. We have to think about the structure of the sentence. Think about the condition versus the conclusion, the condition versus the result, the hypothesis to the conclusion, etc. Other times, we may be pushed to do a little bit of English class here, all right, where we have to write a sentence, kind of convert it from a statement of fact to maybe something that is an if-then statement of fact, all right? So here is a sentence that is true. An acute angle measures less than 90 degrees. This is a fact about acute angles, all right? An acute angle measures less than 90 degrees. So have that down. But then what we want to do with that is write it as an if-then statement. So there's maybe two ways in which we could write this, because this is a good definition for acute angles, all right? We would say that if an angle is acute, then its measure is less than 90 degrees. Or we could say, if an angle measures less than 90 degrees, then it is acute. Now notice a couple things. Notice that I'm using the subject. I'm using an actual noun here, an actual subject for angle. But then in the hypothesis, but then in the conclusion, I'm allowed to use the pronoun it instead of the angle, all right? I don't have to say if an angle is acute, then the angle measures less than 90 degrees, all right? Instead, I have subject, and I'm going to use the word for the subject, but then I can use the pronoun for that subject in the second part of the sentence. Don't put it in the beginning. Don't put pronoun in the beginning. Put pronoun in the second half, right, if you're trying to save writing time. All right? And either way that you do that is correct. If you want to say, if an angle measures less than 90 degrees, then it is acute, that counts. That is a conditional statement, and it is a conversion of that original sentence. A parallelogram has two sets of opposite congruent sides. This again is true of parallelograms, whether you know that or not, remember that or not, but the opposite sides in parallelograms are congruent. Cool statement. If a parallelogram has, how would I write that as a sentence? Well, we have to think about this. If a quadrilateral is a parallelogram, then it has two sets of opposite congruent sides. If a figure is a parallelogram, if a shape is a parallelogram, how do you want to say it? Sometimes there's a word missing from the sentence that is kind of required to make a sentence make sense. You can't say if a parallelogram has opposite congruent sides, because then you haven't said the then part, right? You put the then with the if. So things are getting a little bit weird. You can't say if it is a parallelogram, because we're not going to put pronouns for our subjects in the first half of our sentence. Just kind of keep that straight as best you can. I know that I am not your English teacher, but for those of you that are like, I'm not a math person, I'm more of an English person, you're going to thrive here over the next week or so. All right, so kind of keep that in mind. For those of you that are math people, not English people, hey, we get to do math, and so you're going to love it, right? It's going to be great. Now, each of our conditionals has a truth value. It's either going to be true or false. That's it. All right, there's no third direction. If there is a sometimes situation, then that means there's a sometimes not. And I know that we've always, I'm sorry, not always, but we've already dealt with some always, sometimes never questions. So if something is true, we have to show that it's true always. All right, that's an always situation if a conditional is true. If a conditional is false, which by the way, this is really hard to do. So for example, I said, if I trip on the stairs, then I'm going to be really embarrassed. All right, but I'm sure that there are times that I've tripped on the stairs and I wasn't embarrassed. So that conditional might be true in certain contexts, but it might not be true in others. And so we'd have to make sure that we differentiate that and have a counterexample that shows that conditional in some contexts could be false. To show that a conditional is false, you need to find and only one counterexample where the hypothesis part is still true. If I trip on the stairs, right, that still happens. But then the conclusion is false. Hey, but here I wasn't embarrassed this time, all right? Or, ooh, I didn't study for my test, but I still got a good grade, right? If I study, then I will get a good grade. Here I studied, uh-oh, I didn't get a good grade, right? Sometimes that happens, as that happened to you recently. Think about that. So you have to do only one counterexample. If you're trying to do more than one counterexample, it could get messy, all right? So your job on counterexample is to give only one. All right, and to actually give one. For example, let's do a situation here where we have have to find a counterexample. Find a counterexample to show that this conditional is false. All right, well, if x squared is greater than or equal to 0, then x is greater than or equal to 0. All right, and we can think about that. We can be like, well, 100 is 10 squared, and 100 is bigger than 0, and 10 is bigger than 0. So how do I come up with a counterexample? Well, we want this part to be true, but this part to be false. So where's a situation where x is not greater than or equal to 0? Well, that would be a situation where x is less than 0. Well, what numbers are less than 0? Negative numbers. So we're going to say negative numbers. We're going to use negative numbers here to provide a counterexample. I'm going to show you that negative 1 squared is going to give me positive 1, which is greater than or equal to 0. Yay. That's true. But negative 1 is less than 0. It is not greater than or equal to 0. So the hypothesis is true, the conclusion is false. All right, we flip that around. But notice how I gave an actual counterexample. I didn't just say, oh, I could use any negative numbers. I mean, I said that, but I didn't write that. If it asks for a counterexample, you have to give one. If you just say negative numbers, that will not count because you didn't actually provide me with a counterexample. All right? So be aware of that and be careful of that. But what that also shows you is that power, that we don't have to have like an infinitude of numbers to show that our conditional statement is false. We need 1, and it undoes the whole thing. It renders the whole statement false. I'm going to click back because I skipped a slide. Here, this truth value table can be very helpful in thinking through our situations. We're going to spend most of our time in these top cases because we want our hypotheses to be true. All right? If the hypothesis is true and the conclusion is also true, then the conditional is true. If the hypothesis is true but the conclusion is false, then that means our conditional is false. Right? That's where our counterexample comes in. We find a situation where this happens and then we get a false result, therefore our conditional is false. All right? If our hypotheses are false, then the conclusion doesn't matter. All right? The conclusion doesn't matter. Our conditional will always be true. I know it feels a little bit backwards, but if our hypothesis is false, regardless of the conclusion, we will have a true conditional statement. I know that feels awkward, but that's the way that we are going to approach this. All right, so kind of keeping that in mind, the hypothesis is true, the conclusion is false. Based on the truth table, that conditional statement is going to be false. Okay? All right, example 3 is going to bring us to what is called the converses. All right, so this is kind of a separate concept. We've had conditionals and their truth values with counterexamples, and then now we're going to take that conditional and we're going to rework it and make what's called a converse. A converse is simply switching your hypothesis and your conclusion. Instead of if P then Q, we would have if Q then P. But we have to pay attention to our English grammar. And this is really hard for folks that maybe are still struggling and still learning how to read, write, and think in proper terms the English language, all right? Most of us have been taking English class since we started school, and we're in high school and we're still taking English class. So that tells us something about the complicated nature of reading and writing. And so grammar is going to be a technical skill that we're going to practice and do well with, all right? And I'm going to hold, I know that I'm not your English teacher, but I still want our sentences to sound like the language that we're speaking. I want to offer it that respect, and I want to do a good job with that. Sometimes when we switch these statements around, we will make a converse that is also true. Sometimes when we flip it around, we end up with a converse that is false, all right? And a converse is just a new conditional, all right? It's the same substance, we're just switching around those parts. Even if it comes out false, we're going to write that conditional, even if it sounds ridiculous to write it. So just kind of consider that as we look at this specific example. If 2 lines are parallel, then they are coplanar. So we had that statement earlier. If 2 lines are parallel, then they are coplanar. But if I flip that around, then I want to make sure that we do a good job with it. We are going to say, if 2 lines are coplanar, then they are parallel. So again, we still have the subject here. I didn't just make a hard swap of hypothesis replaces conclusion, because that would have the pronoun they over in this beginning part. If they are coplanar, then 2 lines are parallel. And that sentence is just very awkward to read. All right? So we want to be able to write a sentence that reads well and that sounds correct when we say it out loud. So if you're ever wondering, does this make grammatical sense? Say it out loud. All right? Because if you're reading it out loud and it's very cumbersome and awkward, then it's probably not proper English. All right? And so obviously we'll work with that as well as we can. If 2 lines are parallel, then they are coplanar. If 2 lines are coplanar, then they are parallel. All right? So we want to make sure that we can flip that hypothesis and conclusion. We'll swap those, and now we have a new hypothesis that was our former conclusion, and this is what's called a converse. Now, this statement, obviously, just because lines are coplanar does not mean they're parallel. Lines that are in the same plane can intersect, all right? And so if that happens, then these lines are making a plane, or they're in a plane, but they are not parallel, obviously, because they are intersecting. And so we can think through that truth value to see whether or not they are, to see whether or not this is a true converse by providing the counterexample of a pair of lines that do intersect, and therefore they're not parallel. All right, and here's one that's more algebraic. Conditional statement. If a equals 5, then a squared is 25. This is a true statement. There's nothing wrong with that. When I write the converse, if a squared equals 25, then a equals 5, this is actually not a true statement, all right? It's not complete, because when we think through the fact that 5 squared makes 25, we want to flip that around and think that working it backwards makes for this converse to be true. But it is not true, because we can have A equal -5, all right? Here, I'm writing a counterexample as an if-then statement, so I can show that the hypothesis is still true, but the conclusion is different. It's other than the conclusion that I was provided, all right? -5 squared equals +25. So I actually have two possible answers to this Algebra 1 equation, and I only had one of them here in this sentence. So this sentence was not completely true. I provided a counterexample to show that this person was wrong, all right? Or that converse was incorrect. All right, that brings us to the end. And on the end, the goal there is to make sure that we understand that objective of being able to write conditional statements to find their truth values. Along the way, we learn about counterexamples, we learn about writing converses. There's going to be more to that with converses, contrapositives, inverses, etc., biconditional statements, and we will be working on that in our second video.